All right, welcome to Cardano Sense. Today we are going over Marlowe, as you can see here on the screen. But before we get started, if you have Ada, like to support me, I am running a pool, Sophie, S-O-P-H-I. You can delegate to the pool, or I have an Ada support address if you'd like to support me. All right, let's get to Marlowe. First of all, I'd like to thank Pablo Lamela, Alex Nemish, and Simon Thompson. I'm sure there are other people that worked on Marlowe, but those three, I watched the videos and I read a bunch of their stuff. So I'd really like to especially thank them. So first of all, Marlowe is a smart contract. It is a system, but it is a smart contract written on Plutus, or with Plutus, I'm not exactly sure which is the right terminology, but it is a smart contract. And if you look at this graphic, it's a great graphic. It kind of shows you how Haskell is in the back there, right? And then you got Plutus, and then Marlowe a little bit smaller. Plutus is basically Haskell with a couple changes. And then Marlowe is a smart contract and also a system. So what is Marlowe exactly? Marlowe is a domain-specific language, which means it's made, domain-specific, made for a certain group of people or industry. It is made for the financial industry. Mistakes, they say, are not possible. I don't want to say mistakes are impossible, but it really helps you not make, I mean, it does a good job of catching mistakes. There is a thing here called the static analysis, which we will get into once we start looking at the playground, the Marlowe Playground. It is impossible for money to get stuck, though, the way they wrote this smart contract. So what happens is, I've heard horror stories about money getting stuck in smart contracts, and it's stuck forever, and people lose the money because the code was written the wrong way. In Marlowe, you'll see when we get into it, if a certain amount of time passes and nothing happens in the contract, the money is automatically returned to the account that put the money into the contract. And you'll understand better when we get to it. So, but I'll just say that for now. We'll get to that in a second. I talked a little about the static analysis. Essentially, what the static analysis does is it runs through the entire contract and goes every which way, right? So it takes every possible direction the contract can take and make sure that it runs correctly and there's no errors. And like Solidity and Remix, the Remix kind of playground, Marlowe Playground, you can check the contract before you put it on the chain to make sure it's working correctly. And the last thing I'm going to say real quick, I'm going to get back to this at the end, is this IOHK is planning to implement something, and they probably have already because this is an old thing that I read, something called the ACTUS standard, A-C-T-U-S standard, using Marlowe and Plutus. Basically, the ACTUS standard is the standard by which financial contracts are created. ACTUS was the standard by which DeFi contracts were created, and that's how this whole ecosystem got going with DeFi. And I'll touch on that a little bit at the end, but it's really, really important. I want to make sure people understand that and don't just gloss over that. That is a big deal, especially now with DeFi. But we'll talk about that a little bit at the end. Okay, cool. Without further ado, let's get right into the Marlowe Playground and start coding around a little bit. Okay, so this here is the Marlowe Playground. I will go over all of this stuff as we build stuff. It'll be easier than for me to try to explain it now. On the left, you have the simulation. This is where the contract's simulated after we build it. This is a Haskell editor. I'll get into that. But this is Blockly. So this is kind of the cool thing about this Marlowe Playground is once you figure out how to use this, you can build. There'll be financial industry people that will be able to easily build Marlowe contracts. I've been playing with this for like 3 days, and I don't got it down perfectly, and I'm not a financial expert, so I don't know exactly what goes into these contracts. But I got this down fairly well in 2 days. So what we're going to build here is we're going to build a contract that takes in money from two people, and then a third person decides who gets the money. Okay, just so I can show you kind of how it works. So, all right, the way we build things here is we add blocks. So on the left-hand side, I'll go through this quickly. We have the contract block. This has when, pay, if, let, assert, and close. Observations. So this is like less than, greater than, actions, deposit, like switching or choosing, choices, notifications, values. So this is plus, minus, addition, constants, how much of something. Payee. So this is who gets paid. So a party, like a person can get paid or an account can get paid. This is party. So a role. So you put a person's name there. I'll show you this all in a second. And public key. Token. So this is obviously Ada's in there. And you can also write these smart contracts for other currencies, including fiat currency. Bounds. So bounds, 1 and 2, 0 and 1 is like, true or false. And then you can have, any number between, you can obviously edit the bounds. So let's get right into this contract. Okay, so the first thing we got to do is put a when block in here. And I'll explain all this in a second. We had a when block, and then we have to add money to the contract. So 2 people have to add money to the contract. So we need a deposit into the contract. Now we're going to make this deposit on the side here because once we make it, we can duplicate it instead of redoing the whole deposit. So the first one will be, the first person will be me, Anthony. So I'm making the deposit. The amount of the deposit I'm making is going to be 100. The currency is going to be Ada. And I'm going to copy this, duplicate, and the account is going to be account 0 in the contract here, and I'm the owner of that account. Now I'm going to duplicate this for my brother. So it's going to be the same thing, except my brother Tom. Same amount, same currency. His account, Tom, except his is going to be account 1. So I'm going to put this right in here. So let's stop here for a second. So if this contract gets started and nothing happens and I don't do anything, we want to have a timeout for this contract to just stop. We don't want it just lingering forever. So we don't do seconds and minutes here. We do slots in Cardano. So we're going to say wait 10 slots or wait to slot 10. And if nothing happens, then what we would like to see happen is for this contract to close down. So if I don't do anything, if I just let it go, the contract's going to close. So now we got to put my brother in there. But first, we need another when. And we're going to put him in there. So what's going to happen is I'm going to make my deposit. Then it's going to wait for my brother to make a deposit. But again, we don't want my money to get stuck in there, right? So we have to have something happen here. So 20, we're going to wait to slot 20. And if my brother decides not to play, he doesn't want to put money in there, we are going to close out the contract right here. Okay, so at this point, we have the contract loaded with money. So now we have to put a choice in there. So we need to have someone that's going to choose who's going to get this money. Am I going to get it, or is my brother going to get it? So let's put in a choice block. Here's a choice block. So, before I put the choice block in, we need another when block. And you have to put the right blocks in or it doesn't let you. So there's another when block. So when I'm done, or my brother's done depositing, then it goes here. But then again, if my brother deposits and both our money's in there, me and my brother, and my sister decides she doesn't want to help us out, well, we're going to we want to get our money back, so we have to close it out. So we're going to wait slot 30. We're going to close out the contract. Okay. So now we need the name of our choice here. So we'll call it Who Get It. Who Get It. All right. And my sister is the person who's going to decide. So we'll just take this here, change the name to Rachel. And now I need bounds. What's she going to decide, right? So she's going to decide between we're going to say 0 and 1, and that's basically like true or false, 0, 1. That's just how she's going to, 0, it's going to be, my brother gets it, and 1, I get it. I think is how it's set up here. So, or how I'm setting it up here. Okay, so she's going to make that choice there. So after she makes the choice between those, then we need an if statement to find out what the choice is, to kind of read the choice. So if, then we got to look for the value. If value is greater than or equal to, now the value of what, right? What are we looking for the value of? We're looking for the value of the choice. So here's the choice. So the value of the choice, and the name of the choice is who get it. And my sister is the one making the choice. So if the value of who get it by my sister Rachel is equal to or greater than, we're going to, whoops, I gotta copy it, not steal it, duplicate, is equal to or greater than, we're going to say 1. Then, it's just an if-then statement, then my brother is going to pay me. So here's the pay action. Again, we're going to pull it to the side because we're going to do 2 of these. Okay, so the payee can be a person or an account, so you have to put party in here first. So party, so my brother is going to pay me, so let me duplicate this. What is my brother going to pay me? He is going to pay me the amount of 100 ADA. Duplicate. And it's coming from his account. So there we go. And when this happens, this is going to be the end of the contract, whether I do it or he does it. So there we go. So now we want to duplicate this in case I had to pay my brother, and we're just going to flip it around. So Tom, and then Anthony. Okay, so if who get it is greater or equal to or greater than 1, Tom is paying me, and if it's not, then I am paying Tom. Now we got to make sure the accounts are correct here. I did this the other day, and I had the accounts messed up, and I was trying to figure out why I couldn't pay my brother no money, or 100 ADA out of nothing. So let's make sure we got coming out of the right accounts. So Tom, and Tom's account, actually I think that might be the wrong account. Let me see here, 0101, yes, no, that's right, 0, that should be right, because the account owner, Tom, okay. All right, so let's go through this real quick. Contract. We're waiting. If nothing happens, it closes. Waiting for me to make a deposit. I make a deposit into account 0. Waits for my brother to make a deposit. He makes a deposit into account 1. It waits for my sister to make a choice. My sister makes a choice, 0 or 1. If it's 1, my brother, Tom, pays me, Anthony. If it's 0, else myself, Anthony, pays my brother, Tom, 100 ADA. Okay, so the contract is done. We're going to send it to the simulator. Okay, it is at the simulator. There is a problem here. So when there's a problem, this is what pops up. So let's do a static analysis. So we're going to analyze it and see what the problem is. So it's going through all possibilities, and this is the problem. The problem is the contract is supposed to pay 100, but there's nothing in it. I messed up what I said I didn't want to do. I messed up the account numbers. So I can either change the account numbers here or go back and change them in Blockly. I'll just go back to Blockly real quick, and I'll change them since we made it here. So change this to 1, and this to 0, and that should do it. Let's send it over. There we go. So now we will check it again. Everything is fine. No errors. Okay. So now we have our contract. This is our contract. This was made by Blockly. Now let's go over to the right here, and we'll see the first thing that has to happen is I have to deposit 100 ADA. I'll put it on current state here. So the first thing that has to happen is I have to deposit 100 ADA. It's smart. It knows that I need to deposit 100 ADA. It reads the account. So I'm going to say, okay, I'm going to do that. Bam. Down here, this is the state. The state is I deposited 100 ADA. ADA is the default token, so it doesn't have a token name or symbol. Now my brother needs to do it. Participant Tom needs to deposit 100 ADA. So bam, he does it. There he goes. I did it and he did it. My sister, she's going to choose 0, which means Tom pays me. So let's go ahead and have her do that. She did that. So that's what the state is. Now that's the state. It doesn't show you exact. That kind of shows what happened, but not exactly. So we're going to reset it real quick. And instead of looking at the state, we're going to look at the logs. Here we go again. I put $100 or 100 ADA into the contract. There you go. Into account 0. My brother put 100 into account 1. My sister again is going to pick my brother to get the money, so I'm going to pay him. My brother picks 0. That's my sister picks 0, so I'm going to pay my brother. So this is me paying my brother. The contract pays 100 ADA to Tom. This looks like a duplicate. It is not. Now, because the contract is over and it's impossible for money to get stuck in the contract, since my brother also put $100 into the contract, this second one is the contract paying back my brother his 100 ADA. So this kind of shows how the money can't get stuck in the contract. Now let's reset it again real quick. Again, we both put money into the contract. This time my sister makes a mistake and picks 2. Well, you can't do it. So it doesn't let you do that. It gives you a warning. So she picks me. Okay. All right. So picks 1. I get the money. My brother pays me 100 ADA. The contract pays me back 100 ADA. So that is how that works. The static analysis you saw before, when there was that issue, it showed you kind of what it is. We can analyze it, but there's no issues here. No warnings and no errors. So that's essentially kind of how that works. So I'm going to reset it. Now, the last thing I'm going to show you here is, let's say you want to do this, right? But you want to pay some other people, and you don't want to have to go back to Blockly and change all these names and the amount every time you do it. Well, Haskell gives you a pretty easy way of setting up a template. So this is going to kind of get into Haskell a little bit, and I know a little Haskell, not a lot. So I'm going to kind of just run through this. It should be pretty understandable, but just to kind of give you an example. Okay, so I'm going to copy the Haskell code. I'm going to go to the Haskell editor. So this is just this code up here. These are just different projects. So what I'm going to do is because this is not the project we were just working on. So I'm going to select up to when. If you remember, when is how our contract started. So I'm going to delete this, and I'm going to paste in our contract here, Control V, that we just copied. So this is the contract from this simulation that was created by Blockly. So what we're going to do here, and this is kind of this is the Haskell code. So working with Haskell. So we're going to put a couple variables in here. So we're going to create. This is how you create variables. Or put variables kind of in the Haskell code. So we want to set it up so we have party one, which is me right now, party 2, which is my brother, arbitrator, ARB, which is my sister, and the amount, which is the amount in the contract. So what we're going to do is we're going to copy this, and anywhere it says a role Anthony, we are going to paste this in here. Whoops. We want the one more. Oh, actually, you know what? I think I did. I think I do need. Where did I just put? Yeah, I'm sorry. I do need these around here. Oh, that's right. Okay, so anywhere where it said Anthony, I'll paste those. Now, wherever it says Tom, I'm going to paste party 2. Copy. Here's Tom. Control V. Tom. V, and one more time. Here we go. In between here. So Tom. Control V. I think I messed something up here. Where's party 1? Party, yep. I need to, get rid of that, right? Okay, I think I have to do this so I don't. We'll come back and it'll tell me I got something wrong, but I'm pretty sure. Okay, so wherever it says Rachel, I'm going to put ARB. Rachel. V. Rachel. V. I think that's it for my sister. And wherever there is an amount of money, I'm going to put amount. Okay, I think that is all there. So now, because this is Haskell, this is a typed functional type language, we have to put the types in here. So party 1, party 2, and ARB are all type party. It's a special type I believe they made for Marlowe. Party. And this might look a little weird. I understand this is just Haskell. And then the amount is an integer. So, and you'll see how they all correspond, right? So party 1, party 2, ARB, party, amount, integer, they all go into the contract. So the way we change these now is we're calling the contract right here. So to change these, we have to add them in. So role, I'll put the roles here first. Now you'll see where I'm going with this here soon. And then let's say and the last one is the amount. So let's say the amount is 956,000 Ada. Okay, so let's say whoever wins the race here is going to get the money. So let's put in Ricky Bobby. And Ricky Bobby is racing Jean Gerard, and good old Cal Naughton Jr. is going to decide who won. Naughton Jr. I think that's how you spell it from that movie. Okay, so in this contract where Ricky Bobby and Jean Gerard are the two people who put money into it, the third one here, Cal, is the arbitrator, and 956,000 is the amount. So let's go ahead and compile this. Keep your fingers crossed. And it didn't work. There's an issue. So there's an error. So let's see what is going on here. Parse error, possibly incorrect indentation or mismatched brackets. All right, give me 1 second here. Okay, let me. If this takes too long, I will edit it out. And we're back. All right, I got it. Figured out. Well, not really. I just kind of redid it. So here we are. So we have Ricky Bobby, Jean Gerard, and Cal Naughton Jr. as the arbitrator. And the amount of money, Ada, that's going to be on the line here for this race is 967,000 Ada. So now once we have it like this in Haskell and we've put in the variables, and obviously now if you want to change the names or amount, you just change it here where it says Ricky Bobby or the amount here, and you click compile, give it a good old compiling, and then when it pops up and gets done, you hit send to simulator, and there you go, pop. Ricky Bobby, the money, Jean Gerard, there's the money. So here's the contracts here on the side. So let's run through this quickly. So Ricky Bobby puts his money in. Jean Gerard puts his money in. And it looks like Ricky Bobby won the race. So Cal chooses 1. And bam, down here, if you look, Ricky's money is in. Jean Gerard's money is in. Cal picked 1, and Ricky Bobby got paid 967,000 Ada from Jean Gerard, and the contract paid him back his 967,000 that he put in the beginning just to have the deposit. Now, quickly, let's reset this, and let's say that Ricky put his money in, Jean put his money in, and it was a photo finish, and they're arguing about who won. So Cal decides, I'm just not going to decide. And a bunch of slots move by. Bam! The money is returned to each of them. Jean Gerard gets his money back, or Ricky Bobby gets his money back, and everyone is happy. So that's kind of the cool thing about money not getting stuck in contracts. Okay, a couple more things real quick before we wrap it up. You can save this to GitHub if you GitHub Gist. Also, there's a couple things in here we can go over. Labs, I don't know what these were. They weren't in the documentation, but it looks kind of cool. Obviously, there are more blocks here. So it looks like more functionality. And obviously, there's a way to have this interact with the blockchain, which wasn't in the documentation either. I didn't see it. I shouldn't say it wasn't in there. I didn't see it in what I read. And also with oracles, it communicates with oracles. This is all stuff it talked about in the documentation. And then the last one here is wallets. So obviously this is a way to connect with wallets. Okay, we're going to end this this quick tour here of Marlowe Playground, and I want to talk real quickly about real quickly one more time about I'll give you one. Let me pull it up here. About Actus. So, and I'm going to show you just. Let me click this back over here. Okay, so here's so this, the date on this is January 7th, 2019. So this is before all the big Wi-Fi or Defi stuff started. So let's look here just at this first paragraph. The Actus Financial Protocol, AFP, enables a financial ecosystem in which digital assets can move seamlessly and frictionlessly in and out of diversified portfolio. Now, this was, like I said, back in January of 19, but we know this works very well. There's billions of dollars now in DeFi protocols. And the cool thing is that this language, this functional language, Haskell, was literally made for DeFi. I mean, this is what banks use now and financial institutions use now. And you can't say that, Charles and the guys down at IOHK just stumbled upon this or did it last minute because they wanted to get into the DeFi craze here. They were making this way before this whole big craze. This is the kind of great decisions that happen when you take the time to actually research and write these papers, these peer-reviewed papers. It couldn't be better for Cardano, the fact that they're using this language. You want banks and financial institutions to get into the blockchain ecosphere? This is a pretty good way. This is a pretty good start. Show them something they know already. Haskell. Show them something they're using already. Haskell. Yeah. So anyway, I'm going to leave it there. This is already pretty long. So I'm going to end it. If you have any comments, suggestions, if I did anything wrong or said anything wrong, please tell me. I want to correct it. I don't want to give people bad information. Other than that, I will see you Tuesday with another video. I'm not sure what I'm going to do a video on, but I'll see you Tuesday. Have a great day.